Question 249. On which of the following intervals of x is the graph of this y function decreasing? We know that if y is increasing like that, then slope of tangent line, which is y prime, is positive, right? If y is decreasing, then slope of tangent line, which is y prime, is negative, right? The question here is to look for interval of x where this graph is decreasing, right? So we have to find the interval where y prime is negative, right? So we have to find the derivative of this function, and we're gonna set that is equal to 0, find the critical point, and then we're gonna perform the first derivative test. All right? Okay, let's do this. So y prime is equal to 4x cubed minus 4x, right? So let's factor this. 4x, x squared minus 1, that is equal to 4x. X squared minus 1 is x minus 1 times x plus 1. This is our y prime, and set that is equal to 0. So our critical points are x equals 0 or 1 and negative 1, right? We have 3 critical points, and we're gonna perform the first derivative test. So let me draw this horizontal line. Okay, this is a number line, x. Here we have negative 1, 0, 1 here, right? So we have 1, 2, 3, 4 intervals to test. So this is y prime, right? So we're gonna substitute one of the number on this interval right here. So any number less than negative 1. So let's substitute negative 2. Okay. So if x is negative 2, substitute in the expression factored form here. So if x is negative 2, negative 2, negative 2, you know, this is negative, right? Negative times negative 3, negative times negative, negative times negative times negative. 3 negatives are multiplied together, then that's going to be negative, right? So this interval is negative. Does that make sense? Now let's substitute any number between negative 1 and 0. So probably negative 0.5. Okay, so negative 0.5, negative 0.5, negative 0.5 here. So this is going to be negative. Negative 0.5 minus 1, negative. Negative 0.5 plus 1, that's positive, right? So negative times negative times positive. If 2 negatives are multiplied, then that's going to be positive, right? So here this interval is positive. Okay, does that make sense? Okay, next we're going to substitute any number between 0 and 1. So let's say 0.5. Okay, positive 0.5. So this is a 0.5, 0.5, 0.5. Here, this is a positive. 0.5 minus 1, that's a negative 0.5. Negative 0.5 plus 1, positive. Positive times positive, right? So that's going to be negative. Okay? So last, we're going to substitute 2. Any number greater than 1. Let's substitute 2. So erase this. So if we substitute 2 for x, that's positive. 2 minus 1, positive. 2 plus 1, positive, right? So here we have a positive. So function y is decreasing on this interval right here, where y prime is negative, right? So this interval right here. This interval right here. So the answer has to be interval where x is less than 1 or x is between 1 and 0. So the answer is C, right? Question 253. If f prime is defined by this, where m is a positive constant and m is greater than 1, then which of the following intervals of x is the graph of f increasing? The graph of f is increasing whenever f prime is positive, right? So we're going to find the critical points of f and perform the first derivative test, right? Okay, let's do that. So f prime is equal to mx minus 1 over x squared plus 4, and set that is equal to 0 first. Okay, f prime is equal to 0 whenever numerator of this expression is equal to 0, right? So mx minus 1 is equal to 0, then mx is equal to 1, x is equal to 1 over m, right? Now draw the number line. Draw the number line. Here is x. So we have a critical point 1 over m, and we have two intervals to test. Well, this is the only the critical point, right? If we set f prime is undefined, then denominator must be equal to 0, but x squared is always greater than or equal to 0. So x squared plus 4, this is always positive, right? This is always positive. So we don't have any x value where f prime is undefined, right? So this is only critical point. So let's test for f prime, the sign of f prime. Okay, remember, m is a positive constant and m is greater than 1, right? So 1 over m, this value is positive number, right? It is positive number. Here, 1 over m is greater than 0, positive number, but m is greater than 1. So it is less than 1, right? So we're gonna substitute value that is less than 0, or whatever number that is less than 1 over m, right? So let's just put 0. Okay, so 0 for x. So what's f prime then? F prime is equal to negative 1 over 4, which is negative, right? So this interval is negative. So far so good. Okay, this interval right here, let's substitute 1, because 1 is greater than 1 over m. Then our f prime is equal to, if we substitute 1 here, let's substitute 1 here. Oops, 1. Then that's going to be m minus 1 over 5, right? Remember, m is greater than 1. This value is greater than 1, right? So all of this is positive. So we have a positive here, right? So the interval where the graph of f is increasing, f prime must be positive. So on this interval, f is increasing, which is from 1 over m to infinity. So the answer must be B, right? Question 258. The first derivative of the function f is given by this. Which of the following statements is true about the graph of f? The answer choices here mention about the number of extrema, right? A, it says the graph of f has a 1 relative minimum. B, 1 relative maximum. C, 1 minimum and 1 maximum. D, f has a neither, right? So basically, we have to find the number of extrema in this question. So far so good. Here, f prime is given, so we're gonna find the critical point first. Okay, so set that is equal to 0, right? Here, this is exponential, right? Exponential is always positive. For all values of x, this exponential is always positive. So there's no critical point from this expression right here. Okay, we have a factor x minus 1, 2x minus 3. So f prime is equal to 0 when x is equal to 1 and x is equal to 3 over 2, right? So let's do the first derivative test. So here's the number line. Here we have 1. Here we have 3 over 2. So we have 3 intervals to test, right? We're going to substitute value that is less than 1. So let me just substitute 0. Okay. So here, if we substitute 0 here, 0 here, don't worry about this. This is always positive, okay? So 0 minus 1 squared, that's positive, right? This is positive. If we have a square, this expression is always positive, right? Okay, if we substitute 0 here, then 0 minus 3, that's negative, right? So positive times negative. So that's negative, right? Any value between 1 and 3 over 2, 3 over 2 is 1.2, right? So, 1.5, right? So I'm going to substitute about 1.2. Okay? So, if we substitute 1.2 for x, here, I'm just going to substitute 1.2 here. That's a 2.4 minus 3. That's minus, right? Remember, this is always plus, this is always plus. Don't worry about these factors, okay? So 2.4 minus 3, that's minus. So here we have a minus. Now substitute maybe 2 now. So since the 2 is greater than 1.5, substitute 2. 4 minus 3, that's positive, right? So here we have a positive. So let's look at the behavior of the graph of f. F prime is negative, then f is decreasing here, right? Still negative, decreasing, positive. What happens? It increasing, right? It increases. So we have one relative minimum at x equal 3 over 2, right? So the answer has to be A. The graph of f has one relative minimum, right? Question 263. If f of x is equal to 1 plus 2x to the power of 2 over 3, then which of the following is true? We have 3 parts to think about, and it says f is differentiable for all real numbers. Second part, f is increasing for x is greater than 0. Third part, f has minimum at x equals 0. So basically, we have to find the derivative and perform the derivative test and see if each of these are true, right? So the derivative of f prime. Here, f prime is equal to derivative of 1 is equal to 0, so I'm not going to write it. So that's just the 2 times power of 2 over 3 x to the negative 1 over 3, right? 2 over 3 minus 1 is negative 1 over 3. So that is equal to 2 times the 2 over 3, that's 4 over 3, and we have x to the power of a negative 1 over 3. That's cube root x in our denominator, right? So this is our f prime. So let's find the critical point. Set that is equal to 0. Well, this expression never equal to 0, right? So there's no x value such that f prime is equal to 0. Okay, set f prime is undefined or undefined. Well, f prime is undefined when x is equal to 0, right? So that's our critical point. This is our critical point, right? It is because when x is 0, the function is continuous, right? So yeah, x is equal to 0, that's a critical point. So we're gonna do the first derivative test now. Let's draw with the black. Okay, so here's a 0 f prime. So we're gonna test these two intervals. All right, so when x is less than 0, let's substitute -1. Okay, -1. If x is negative value, all of this expression is negative, right? Because the cube root to -1 is -1, right? So we have negative here, right? If x is greater than 0, let's substitute 1 here. If x is 1, then all of this expression is positive, right? 4 over 3 times 1. So that's positive. Positive here. So the graph of f decrease in this interval and increase in this interval, right? So we have relative minimum at x equals 0. So that's true. This is true. Second part, f is increasing for x is greater than 0. Is it increasing? Yes, because f prime is a positive here, right? F prime, oops. Yeah, f prime is positive here, which means f is increasing on this interval, right? So this is also true. Is f differentiable for all numbers? No, right? At x equals 0, if x is 0, f prime is 4 over 0, which is undefined, right? So f is not differentiable at x equals 0. So the first one is not true. And the graph of f actually looks like that, okay? So this is cosine of this function, which is not differentiable at this point, right? So the answer has to be 2, 3. So the answer has to be D, all right? Question 266. The graph of f prime is given above. Well, actually the figure is right over here. The question is how many relative extrema, minimum and maximum, right, will the graph of f have? Let's say we have this number line with a critical point A and B. Let's say here's A, here's B. If the sign of f prime changes from positive to negative, then we know that f has a relative maximum at x equals a, right? Because it increases up to this point and then it decreases, right? If the sign of f prime changes from negative to positive, right? Negative to positive, then we know that f has a relative minimum at x equals b, because the function f decreases here and then increases. So far so good? So now let's look at this figure right here. Here, this graph is f prime, the graph of f prime, right? Here, if f prime is above the x-axis, this part right here, that means f prime is positive here, right? Does that make sense? Let's say when x is this value, f prime is a positive whatever, positive 1, positive 0.5, positive 0.3, 0 here, and then the graph is below the x-axis, right? That means f prime is negative here, right? Like when x is 0, negative 1, negative 2, negative 1 again, negative 0.5, right? Do you guys see that? So here is negative. Below the x-axis, negative. This point right here, f prime is 0, right? These 4 points, at these 4 points, f prime is 0. 0 here, and again, below the x-axis. So negative, right? Negative, negative, 0 here. Now positive, positive, 0 here, negative here, right? So look at the sign of f prime. F prime changes from positive to negative, right? If the sign of f prime changes from positive to negative, we know that f has a relative maximum at this x value, right? So f has relative maximum at x equal 1, right? Here, negative, 0, negative, sign doesn't change, so we don't have anything here. Negative, 0, positive, the sign changes from negative to positive, right? So at this point, at x equal 5, we have relative minimum, right? If f prime changes negative to positive, f decreasing, increasing, which means we have a relative minimum at this point, right? So at 5, we have f, minimum of f. F has a relative minimum at x equal 5, right? Here, positive, 0, negative. F prime changes from positive to negative. At this point, we have again relative maximum, right? Relative maximum of f, right? So how many extrema, how many minimums and maximums? We have a 3. 1, 2, 3. So the answer must be 3. Okay? Question 267. The relative minimum of the slope of the curve f of x is at what x value? That's the question, right? It is asking us to find relative minimum of the slope. Slope of curve of f is f prime, right? So slope is f prime. So we have to find relative minimum of f prime. Here f prime is 12x squared minus 12x. So we have to find relative minimum of this f prime. Remember, to find relative minimum of f, let's say relative minimum of f, what we did is we found the critical point, right? Critical point, let's say critical point is A. Then we test it, right? So let's say f prime is negative to positive. Then we know that f is decreasing in this interval, increasing in this interval. So we know that f has a relative minimum at x equal a, right? That's what we did. Here we're trying to find relative minimum of f prime, right? So relative minimum of f prime. Then what we have to do is we have to find the x value where f double prime, second derivative, is equal to 0. Let's say this value is b. Then we test f double prime. Let's say if this is minus plus here, then we know that f prime decreases here, increases here, right? You know, this one is f prime is first derivative of f. F double prime is the first derivative of f prime, right? So if f prime negative positive, f decrease, increase. If f double prime negative positive, f prime then decrease, increase. Does that make sense? Okay. So let's find the value of x, this x, where f double prime is equal to 0. So f double prime, well, let me erase this with a black. F double prime x is equal to 24x minus 12, right? Set that is equal to 0. So 24x is equal to 12. Then x is equal to 1/2, right? So we're going to test it right here. Here's 1/2. Here's f double prime, right? Okay. I'm going to substitute 0 for x. So if we substitute 0 here, f double prime is 0 minus 12. Negative here, right? Let's substitute 1. If we substitute 1 here, 24 minus 12, that's a positive 12 plus here, right? So f prime decreases in this interval and then increase after x is equal to 1/2, right? So what's the answer? The relative minimum of the slope of the curve. Slope of the curve. It has minimum at x equal 1/2, right? So the answer must be 1/2.